Next point of today's talk is the RapidScan technology. Rapid or so-called fast scan is the topic in AFM community that is widely discussed um, for these last 10 years or even more years. And there are two commonly used terms. First term is the high-speed AFM that is usually referred to the video rate AFM working with a scan speed of 10 till 100 frames per second or even with a higher speed. And this FM has its own niche, but they have small sample sizes usually. They allow topography imaging only, usually. Uh, these kind of instruments are very complex to operate with, and they have small field of view. Another group of so-called fast-scan AFM is usually referred to the smaller field of view compared to regular AFM, and the scan rates that are about 10 times larger than the typical scan rates in AFM, and that corresponds to about to the order of 10 lines per second. Well, the key in this presentation we will talk about the fast scan option, and for this option the key limiting factor is actually the mechanical resonance of the scanner. We have been lucky enough to have a chance to check the well-known formula from the school physics, from the physics school book, about the dependence of the resonant frequency of the spring loaded with some mass, and these formulas works perfect, especially for scalar resonant frequencies in both XY and Z direction. And the resonant in XY direction is usually the limiting factor that pushes developers to decrease the field of view and scan rate in XY direction, but to get the higher scan rates. We propose the RapidScan 100 technology, and this is the combination of mechanical design and digital electronic solutions that allows to speed up atomic force microscope by an order of magnitude approximately, but keeping the same field of view in XY direction, keeping 90 microns in plane scanning range. So the idea here is to damp digitally scanning resonance in X and Y using a combination of low pass filter and high pass filter and band pass filter, and as the result in this picture it is clearly visible that the resonant characteristic of the scanner becomes much less resonancy. And then keeping the same scanning range of 90 by 90 microns, it is possible to scan not just the atomically flat surfaces, but also the rough surfaces like a collagen surface in this example, with a scan speed of about 10 lines per second. And there is, by the way, 1000 points in each line, because usually when demonstrating the fast scanning in some IFMs, usually the manufacturers decrease the amount of lines, the amount of points in lines in X direction and the amount of lines in Y direction. Here there is 1000 by 1000, so there are 1000 by 1000 lines in each direction. And as far as we can see, this is the forward and backward lines are shown in the cross section. They're quite correlative. We can see that we're able to do this kind of scan even on very rough samples. Another example that is quite typical but quite difficult for both automatic adjustment and for the fast scanning is the calibration grating. The calibration grating is a standard, let's say, test signal, like a step signal for any adjustment system. And in this example, it is shown that we can automatically and rapidly scan this kind of sample with the speed of 10 Hertz, having at the same time 1000 points in each line and having 1000 lines along the Y direction.